Okay, so let's continue to look at one more example about the how to define whether a system is consistent or not. Okay, look at this example. So given x1 minus 2x2 plus x3 equals 0, and then 2x2 minus 8x3 equals 8, and then 5x1 minus 5x3 equals 10. Okay, so we want to determine if the system is consistent or not. Okay. Alright, so what we can do is we can write it down, the augmented matrix, which is 1, negative 2, 1, 0, 0 to negative 8, 8, 5, right, 0, negative 5, and 10. So from the first video, we talked about the elementary row operation, right? So after you do a couple of row operations, you're going to get a row equivalent matrix, and then correspondingly they're going to have the same solution set. So so our focus becomes, okay, let's try to use the forward elimination, trying to see if we can construct the coefficient into a upper triangular shape, and then to determine, whether it has solution or no solution, etc. Okay, so to do that, as you can see, row 2 and row 3, they both have some common factors, right? So row 2, if I use row 2 divided by 2, right, let it becomes new row 2, and row 3 divided by 5, let it becomes new row 3. So we have 1, negative 2, 1, 0, 0, 1, negative 4, 4, and I have 1, 0, negative 1, and 2 here. Okay. Alright, so once we drive this, as you can see that we can use row 3 to subtract row 1 and let it become the new row 3. Okay, so as you can see, 1 minus 1, this is 0, so 1, negative 2, 1, 0. Row 2, nothing changed, right? So this part becoming to 0. 0 minus minus 2 become 2. Negative 1 minus 1 becomes negative 2. 2 minus 0 becomes 2, right? Okay. That's what we get. Alright. So if we continue to do this process, actually we can let our row 3 divided by 2, right? Because it has common factor. So we have 1, negative 2, 1, 0, 0, 1, negative 4, 4, 0, 1, negative 1, 1. Okay. So now, what we can do here is we can use row 3 to subtract row 2, right? So that, as you can see, 1 minus 1, this part is gone, and then let's do that. So it's 1, negative 2, 1, 0, 0, 1, negative 4, 4. We have 0. So to 0. So this minus negative 4 become plus 4. So we get 3. As far as negative 3. Okay. So negative 3. Okay. Cool thing. All right, so that's something we can have. Okay, we can have. Now, if we continue to do this process, as you can see, well, we can still let our row 3 divided by 3. Okay, so now this is what we get: 1, negative 2, 1, 0, 0, 1, negative 4, 4, and 0, 0, 1, negative 1. Okay, negative 1. All right, so looks like we're good at this part, but let's try to solve this. You see, from here, the equivalent system is x1 minus 2x2 plus x3 give us 0. Okay, and the same thing, x2 minus 4x3 equals 4, and x3 equals negative 1. Okay, equals negative 1. So we drive this, and then if we plug into 2 here, you can see this is negative 4 times negative 1 become positive 4. So it's x2 plus 4 equals 4. You can drive that x2 equals 0. So, and then if you plug this is 0, this is negative 1, so you drive that x1 equals 1. Okay, equals 1. So this is one of the examples we can see. And apparently, up to here, you see that since we already constructed into one upper triangular for the coefficient matrix, so from here directly we can read out that the system definitely is consistent. And not only it is consistent, but it has one unique solution. Okay, so that's a very simple example about this. Okay, so hope you enjoy this. We'll start the next section soon.